Right. Okay. So I have to record this video again because there was no sound. Right. So in this video, I want to share with you something really cool that I discovered, which is a software called Tracker. Now, what this software can do is it can auto track any moving objects in a video and calculate the velocities and the accelerations. And that's really cool. So now I don't have to analyze it myself anymore. Um, it can instantly analyze every single frame in a video, and it can give us the X and Y coordinates of every single frame, and then it can calculate the velocities. So let me immediately show you an example. I'm going to use my latest Newton's cradle, well, basically two marble collisions of the 1:3 mass ratio. So let me open up that video. And so what we have to do, we have to select an area um, of the ball. Well, we can also select the entire marble, but the problem is that's a rather big area. And what's going to happen is that's since it's a big area, it takes a lot of data to consume for the software, and it's going to start lagging. So ideally, we should be able to select a small area that it can track. So what we can do is I have glued a couple of small nuts on top of the marbles, and we can select this uh, area that it can track. For example, so I have to create a new track. I'm going to click point mass, and then I have to click here, show or hide the auto tracker. All right. Now I have to select the area that I want it to track. So I have to hold down Control Shift and then click over here. All right. And then I'm gonna create the area that it needs to track. So you can already see over here. So I have select, I can, when I can change this. Hold on. All right. This is the area I wanted to track. All right. So, and then I have to press search. And then for every single frame, it's going to track that selected area. Now, sometimes it may not be able to identify the selected area in a certain frame. So it will ask me, is this the frame? Is this the area that you want me to track? Is this the right selected area? And I have to do yes, accept. So for example, I'm gonna now click search, and then for every single frame, it's gonna track that area. And it's gonna give me the X and Y coordinates for every frame. So now it asks me, frame 127, a possible match was found in the search area shown. So this was my selected area, and then it asks me, does this match the selected area that you have selected? And yes, it does. So I have to do accept and accept again. So right before collision is going to ask me this a couple of times. All right, now it continues on its own. It's able to auto track it on its own. And now that's enough data. I'm going to stop. So now we can see here a graph of the X coordinates and the Y coordinates, which is cool. And then over here we have some columns, some tables. Now we can add the most important part, the velocity magnitude table. So let me show you that. So now on the very right here, we can see the velocities for every frame. And so we can see that, so it starts with 367 and it's accelerating. 389, 397, 399, 412. So it's still accelerating right before collision. So let's take a look what the highest number is. 415, 428, 437, 444, 437, 429, 451. And after and then 431, it starts to decelerate again. 440, 439, 406, 443, 396, and 147. Then suddenly there's a sudden drop, a quick drop of velocity, which means this is at the point of collision where the velocity quickly drops, becomes 0, and then it reflects. So we can see that the maximum, sorry, the maximum velocity before collision is 451. Sorry, I have a little cold, I guess. 451 before collision, then there's a reflection, and then you can see, so 133 is the lowest velocity, and then it starts to accelerate again. 204. So, all right, so 451 is the maximum velocity before collision. So we expect after the collision that it will reflect with half the velocity, which is 225. That should be ideally the velocity after collision. So 225, let's see what happens. 199, 204, 202, 200, 215, 222, 217, 222, 222. So we see that the maximum velocity after collision is 222. All right, so we have a 450 and 451 and 222. Let me grab my calculator. 451 and 451 divided by 222, which is 2.03. So that's almost perfectly twice as slow, so half the velocity. So now let's track the tree mass. So I have to create a new track, point mass, and then auto track. And so we have to go back here, right before collision. Hold on, pause. I'm going to select this area that it needs to track. All right, and search. That should be enough data. And we're going to add another velocity component here. All right. So we start with 82, and it's going to accelerate. 185, 202, 200, 202, 202, 201. So it seems like the maximum velocity is 202. So it's a little bit slower than the one mass reflecting back. So they're not identically half 202. So 451 divided by 202, which is 2.23, which means the tree mass went 2.23 times slower than the initial velocity, which is still closer to half the velocity, rather than 4 times slower, as some other people might think happens. Still a lot more closer to two times slower than 4 times slower. All right, so now let me show you another example, another video. So replace the video with an older one, another 1:3 mass ratio collision that I did. Hold on, there it is. This was like from a year ago. So first I have to delete these tracks. Okay, add a new track. Then we're going to track. Oh yeah, so I already tried tracking this video, and it asked me constantly, is this the right selected area? Is this the right selected area? What we also can do is we can select you can see there's a light reflection on the marbles, right? This bright spot here. We can also track this, which is a lot easier for a software to track. As you can see, this bright spot also moves along, right, with the marble. So we can try to track this. Let's see. Okay, so we're going to track this area. Hold on. No, let me zoom in. All right, yes, this. And now search. And there we go. So there seems to be no problem. It doesn't ask me to say, does this match the selected area? No problem. It does it all on its own. All right, let's press stop. And then add the velocity component. All right, let's see. So it start with 1 and then 0, and then it's accelerating 15, 19, 21, 43, 54, 70, 90, 118, 132, 156, 162. It goes all the way up to a maximum of 206, 209, 211. I think it seemed like 211 is the maximum velocity before a collision. After this, we can see a sudden drop. It goes from 211 to 30. So this is the point of collision. So 211 is the maximum velocity. So we expect half the velocity, so around 105. Let's see what happens. So 30, 95, 103, 98, 102, 101, 100, 103. So we see 103 to be the maximum velocity after collision. So during the reflection. Okay. So 211 divided by 103. 2.04. So once again, around 2 times slower than the initial velocity. Half the velocity. Now the tree mass. Let's go back before collision. All right, another track, new track, point of mass. All right, and we're going to select this bright spot here. That needs to be tracked. All right, then search. Oh, but see, it still asks me. Yes, this is the same frame. All right, the same. All right, let's stop. That's enough data. And add the velocity here. All right, so let's see. So it starts with 0, then it starts to accelerate. So 211 was the initial velocity. So we expect around 105. So 56, 95, 103, 102, 95, 96, 96, 98, 94. So we see a maximum velocity of 103. So it's again 211 divided by 103. It's the same actually, right? 2.04. So also the tree mass lifts off with around half the velocity. It goes around 2 times slower than the initial velocity. So again, so even the velocity, even the software calculates that for a 1-3 mass ratio collision, that after collision, both balls lift off with around half the velocity, half the initial velocity. Not 4 times as slow, but very close to 2 times as slow. Now, if this doesn't still convince you, yeah, you might call it a crap software, I guess. It's a crap software. Yeah, let's say it's a crap software. This is garbage. We need better than just All right, so just to show you that no matter how we analyze it, it's always half the velocity. All right, let's stop the video.